Welcome to this session about MySQL Kubernetes Demystified. Okay, first question. Who knows what this is? What is this? Well, no, no one. Okay, I will not tell you. Okay. Of course not. You will discover later. Okay, Marco Tusa, open source enthusiast and tech lead in Percona and so on and so forth. You are not really interested on that. Today this session will be split in two main parts. One is a little bit of history and why, and then we will cover the how part, and we will see what needs to be done in general overall to have a Kubernetes cluster working in the sense of the architecture, and then also some settings that could help you to keep it alive. And this talk started a few years ago in my mind, because I was reading an article over and over about Kubernetes and databases and how to scale with Kubernetes for databases, and I was a little bit annoyed by that, because I don't think they were covering what should be covered when we talk about databases. And especially, they were not making a differentiation that is quite important. Also, today, we have listened a lot talking about databases, but database is a file, CSV is a database. You know, a time series is a database, right? So what we are talking about, MySQL is a relational database management system, is different, okay? And that has never been really brought to their attention when we talk about scaling and other stuff. So just saying or promoting the Kubernetes and containerization for databases like RDBMS for scaling reason, for me, was a little bit annoying. So it is also fun that today, during the keynotes, both Peter and don't remember the name, Rachel did an analysis of the whole back time, you know, when a long time ago. Well, I started working in '87 in this field, and you know, this is the list of the databases that were existing at the time. MySQL is not here, and Postgres came out probably the year after or something like that. And you know, applications were like this: client server, one transaction, one connection, once a while, some write. So it was very simple for servers to manage. Then we have the internet and the web application starts, and then we start to have definitely more traffic, right? And the application, the monolith that we were having before, didn't work fine anymore. So we had to move to a new approach. And we have the service-oriented architecture. I don't know any of you programmers remember this? Of course, yeah. You know, this is what we have seen, the evolution, right? From COBOL to something a little bit more advanced. So we move ahead, and we have this kind of separation of the functionalities inside the architecture. And then, you know, that was not enough, because the traffic increased. And we move from SOA and a monolithic approach to microservice. And microservice is actually what we still have for application, right? Splitting as much as we can and duplicating in a stateless mode what is the functionality of the applications. So if one node, one pod, one pod crash, the service survive. And the interesting thing is that I put here database. I'm very positive, but it's not what we actually had. Anyhow, and here we go, the image before. This is the graph of microservice from AWS in 2008, and it was called the Death Star. okay? So what you were seeing before is this thing, 2008. Guess what they have now? I have no idea. I mean, what they call the black hole. This is a huge and unbelievable composite system. But yeah, this is what came up for in 2008. And of course, the database evolved as well, right? From 87 to today. This was a database and a relational database, okay? In 2087, this is what we have today. It didn't change a bit, okay? It didn't change. We just have more bricks for high availability, and that's it. Instead of having one node, we have multiple nodes for clustering in order to serve in case of crash of one of the nodes to keep up the system alive. So what was the benefit of all this scaling and splitting and dividing? Of course, for application, we had a lot of benefits, right? Modularity, because we can have different function and different split here and there. The scalability, because with the microservice we can scale multiple pods and then serve the same function over and over, and so on and so forth. I'm not going to cover all of them, otherwise we will stay here for long. Actually, I have the time, but yeah. What instead have happened for the database, if we apply the same model, right? We want to apply the model that we were having for the application, also for the database. Well, modularity. Well, about modularity, we cannot really talk about the same approach of what we have for the application, so splitting in small functional things. But we have two ways of being modular. One is by service, which is trying to isolate the functionality, like a login. I need for a login, I need username and password and something like that. Or by context. By context means, for instance, if you have a server with that has a database that is hosting, sorry, it doesn't come the term in English, but so I will describe in a different way. So if you have a multi-tenant, a multi-tenant database, you can split the data, right? By, for instance, I don't know, if you have multiple shop that you serve by shop, something like that. In terms of scalability, again, the problem is if you split the database in multiple pods and you pretend that to have the relational database serving, then you need to have a system that actually manage distribute locking, right? Because whenever you do a write, whenever you do a transaction, you need to have a distribute locking mechanism that allow you to be sure that you respect the asset paradigm. And okay, the others, I mean, just keeping. But let's go back, the reality. I was showing you now all this kind of nice database label at the end of the service. What the reality is that in the application you have many services and one database at the end. So most of the services at the end go to one single database source, relational database source. So you are not really scaling anywhere here. And also, when you actually adopt a solution like MySQL, Percona operator from MySQL, what you have, I don't know if you have seen this graph before in the other presentations. Never? No one was showing you. Okay, fine. What you actually have is the graph represents one single service. So, for instance, if you have database for, I don't know, whatever kind of operation you do, and you have one single service, and then you have multiple layers. So the application layer, the application up there that connects to the load balancer service, which will redirect, to the different pods for the proxy level. Instead of proxy level, you have multiple service, which are the proxy itself, the health monitor, the PMM client, if you have PMM activated, and then you redirect to the data node, which has the log service and PMM client as well. So what happened is that you have one big service, multiple node, but at the end it's still one single service, right? So far what we have seen, just a small recap too, because I understand it could be confusing all this. We had a universal scalability for the application, right? And zero scalability for what we have in terms of database. Also, if you're using the operator and Kubernetes and database and Kubernetes, relational database and Kubernetes. What you have is horizontal scalability for reads, of course, but that is the same thing that you have, for instance, if you install a PXE cluster, right? If you install a PXE cluster, you have one write and multiple read. And so what? Now, all the problem starts from this, right? From the concept of relation. In a relation database model, you have a schema, and then you have tables that are correlated one with the other. And the problem here is, whenever you do an operation, you need to be consistent. You need to be sure that whatever you do is actually permitted by the other table correlated. So if I have, let's say, a customer, I cannot have, for instance, an order without having a customer. I cannot have a payment or a shipment without an order. So whenever I do an operation, I need to be sure that everything is consistent with that. So I cannot really split, right? I cannot really just say this segment is going, this segment of my tables is going in this part, in this service, and then I have a service that say customer payment and another service say orders. Unless you can divide the thing. And if you can divide the thing, like in this case, how I was showing, isolating, let's say, only order, then you don't need a relational database. So why are you using MySQL at all? You can use whatever other kind of data store or data like that allow you to scale in a more efficient way. Pardon me, I need to drink something, otherwise in 2 seconds I will have no voice. Any questions so far? No, all clear, fantastic. So, if the only way I can do some level of scaling is by context. But the point here, as I say, multi-tenant can be a good case, right? But the point also here is that whenever I use a solution like MySQL operator, the one we have, those solution is based on technology like PXE or group replication that, or also the other version that we have that is asynchronous, that actually allow you to have one primary at a time, you know? So also if you do that, there is no distributed writes. So the scalability of these solutions, again, is known. You cannot scale by, let's say, by service in this case. So the only way you can scale is sharding. Now, the point of sharding is to split the data, so not the schema, right? The schema remains the same. The design of the database remains the same, but you split the data in multiple pieces. So you can decide to split by geographic region or by, I don't know, gender. Well, gender is not really efficient as a sharding mechanism because well, today you have multiple than binary, but that's another story. It could be, I don't know, whatever kind of shop name or shop ID or location shop ID, combine whatever you want. So sharding is fragmenting the data and is absolutely complex. It's very complex to have a sharding mechanism that works perfectly. So, and you have normally three ways of sharding. One is application by application, so by application is aware of what you're going to do, or the application just have access to some kind of catalog and decide which kind of tag insert in the query in order to use, to let then the mechanism that you use for the shard to redirect. The tag could be also the simple fact that you need to use all the time in the workflows the specific ID, for instance, select where nation equal bar, right? It doesn't need to be in the comment or whatever. And that's it. I mean, there is actually the third one, no shard where passive information generalized is the same thing. It's just the fact that the application doesn't have any knowledge about what the catalog is. It's just using that information. The point is the first thing, also today we had the MySQL roadmap, and one of the questions that was that came out is what level of, there were people implementing different sharding mechanisms, and one of the questions was why you didn't choose to go for application, right? Application sharding, because it's obvious answer was it's too complex, not only to implement but to maintain, because every time you have to in some way manipulate the code, that this is absolutely something that we don't want to do. That's absolutely normal, right? And so the third way of sharding assume that you have a service dedicated like that. It could be as simple as a proxy SQL with query rules that redirect, the query to a specific shard group of nodes, or it could be a complete solution. Also, if it has a lot of problem, as Pavel was showing in his presentation. I mean, you were presenting that in the other room before, so it was quite interesting to see also how implementing in that solution by GitHub, that people that knows how to do stuff, it was long. It was long, right? It was taking a lot of time and effort. So it's not something you do right away. But the only way to do it is sharding. And if you want to use one of the concepts, okay, let's go back to why we can use and why I was annoyed. I was annoyed because it's too simple to say you can shard with the operator or in Kubernetes, but it's possible to do it, but it's complex, okay? And it's possible to do it with architecture like this, where you have, the proxy SQL microservice on top, and then you have your application connecting to that, and then when you redirect to multiple shards, okay? Something like that. And if you do sharding with proxy, it's very simple, is the simplest solution. The problem here is that you cannot, you do not have, for instance, an automatic mechanism to implement resharding. So if you have to rebuild the shard, you have to recombine the shard, you have to do it manually. But if you do that, I did a simple, stupid POC just 1 week ago, something like that. A stupid POC where I put 2 different shards, and actually I was having fun because I was combining one shard that was based on PXE and the other shard based on group replication, and one was using a lot of resources and the other one was using only a fragment of the resources of the first shard, just to see how unbalanced the shard could work. And also with this kind of situation that was quite weird, I had, evidence that it is easy, it is possible, it's the way that makes sense to do it, and it's also having some good results. Anyhow, and latency also was that dramatically, not dramatically, but it was contained by the fact you were sharding. Now, let's start to dig a little bit in the operator and the Kubernetes operator and all the problem that it brings in. If you use a solution like the operator, the MySQL, Percona operator for MySQL, one of the problems you will start to have is the dimension of the data set, right? The bigger is the dimension of the data set, the longer you will have to wait if a node is destroyed, if a pod is destroyed and recreated. Any of you use in production or also in test a kind of solution based on operator and for database? None. So this is a completely you. Okay. What kind of operator are you using?
We have an operator
For Vitess. Okay, for Vitess. So Vitess, MySQL, and okay. Now, is the dimension, okay, how large is the largest dimension that you have in the, of the database for the pod? I mean, the largest database for the, you have operator, you have Vitess, so you have a shard. Each shard will have a dimension of the data, I don't know. 1 terabytes, what is the biggest one? No, but per pod. Per pod.
I have no idea, because I don't have any information on how many pods people have.
Okay. Let me put it in this way. Thank you. The larger the dimension per pod you have, the longer it will take for the pod to be rebuilt. Because if it crashes or if it's destroyed, it will need to be rebuilt to restore the service at 100% of its efficiency. And why I'm saying this? I'm saying this because in the Kubernetes world, whenever we work about operator, multi-service, is the service that makes sense, that it matters. It's not the pod, right? So also when you have a database that is based on 3 pods, what it counts is the service. It could happen, because it happened, that one of the pods is evicted for several reasons, and the service is up. And normally for applications stateless, you say, who cares? It's okay, right? But for database, the fact that a pod goes down and needs to be rebuilt, it takes resources, and you have a service degradation. Yes?
Like, we don't use any operator or anything, but I know that Activision, they recently gave a talk. They have a 30 terabyte database, and I think their pod size is 300 gigabytes per.
Yes.
Something like that, just so they can make sure that they have like a time for restoring pods that makes sense for them, like that they can like feel acceptable.
That's exactly the point. What we see as good dimension is between 250 if you have a high level of writes for the solution, up to 1 terabytes when you have instead mainly reads, right? This is the kind of range where we are working. So if you have, for instance, a database that is 40 terabytes, either you shard and go for operator, or it doesn't work for you. This is a very important thing. And of course, if you go for sharding and for you need to have an archive mechanism and so on and so forth. Now, until now I have spoke about this because scalability and sharding, but the pod is actually the PDMO, Percona MySQL operator, is actually extremely efficient also for other solution, like for other reasons, because it helps you all the automation part, right? So all the installation is done by mainly 3 commands, which are the one that you use to run on Kubernetes to create the environment for the service, and then to create the pod itself. All the backup and restore things are completely automated and are done by the service by schedule or on demand, but it is very simple and completely automated. The point-in-time recovery also is another feature that we have that is allow you to recover the data exactly at that point in time through streaming the binary log into S3. And, and this is all done using the operator and simple command. So it's not useful only for eventually sharding, but it's because simplify the operations. The other point that is very important is, now my colleague is not here, but what the Miha, which is very, okay, anyhow, he actually called it the Tetris game of Kubernetes. What is the Tetris game of Kubernetes? Mainly, you have containers, and you can actually, the optimal way to use the containers is not just to create one solution in terms of physical, of virtual nodes and one container, but to split, to have a larger solution and to optimize the resource based on what you need. So you have multiple service on the same physical node, okay? And that, for instance, if you apply that mechanism on an AWS solution or an AWS rollout on AKS, and you then compare the cost of what you have with using Percona operator for MySQL and Aurora, and I'm talking about comparing dimensions and performance, because that is also another test I have done, and also another blog. For similar or better performance, you save a lot of money, because, for instance, in the case you have this for the operator on just 4 CPU, and on a RX5 large multiple instance, it will cost for service 1,800, while in Aurora is above $6,000, and you get the same level of service, right? So playing with this game of tuning the resources based on what you really need on large boxes, or it could be virtual machine, or could be in the cloud, it will also make a lot of sense. And the fact is that if you use the operator, the resource change is easy, because you just have to change, the resource flag, the resource directive, and that is it. This also helps you a lot when you have, load that is close to the saturation. So you don't want, for instance, you have a machine that is on RDS, you have a machine that is this 32 CPU, and you just need a little bit more. But the next step is 64 CPU with a huge jump of money, right? Well, if you have you can play the Tetris game, you just need to do a small increase on your directive, and that will be sufficient for you to go ahead and have your service working. However, yes, let's keep. I like to reiterate this because it's important. Large data set is a big problem, okay? And you also also need to be careful about network glitches that, especially if you work on the cloud, you have unexpected behavior, and that could actually lead to operator to kill a pod just because there was a network glitch, and the probe that is listening and monitoring the pod just decide to kill it, and then you have service degradation because the pod needs to be rebuilt. again, so what possible architecture we can have? The simplest one is this one. You know, you have one single service with a peak C over it, well, with a Percona operator for MySQL with peak C over it, and that's it. Or you can use the similar architecture, but with geographic replication and asynchronous replication. And by the way, the synchronous replication is also implemented automatically as part of the functionality of the operator. So what you have to do is just to create your service on the site A, create the service on the site B, and then tell to point the site A to site B and vice versa. And that's it, right? And all is done automatically. Or you can have a little bit more complex architecture like this one, where you have the sharding implemented with proxy SQL, for instance. Now let's go to the settings. Actually, I'm running like hell, so also too much. Sorry, guys. So the first thing that you need to do is to consider what I was saying before. Unless you have your environment on your own private cloud, if you go for the GKE or AKS, something like that, do not take the node, the basic node, for one single service. Always take the choose the dimension of the node based on hosting multiple services. That will allow you to have better cost-effective cost benefit. And always also check when you deploy that the multi-availability zone is inside, is in place and that is correctly distributed. Verify the network. That is also not another thing that is very important, because network has a very huge impact on how the operator works. Well, actually, this is dependent by the technology, but we are talking about MySQL, so it's definitely very important. And finally, the storage. In Kubernetes, you can define the storage class. And what is absolutely important here is to do not use the default, for instance, GP2, the default class, right? Because the performance are absolutely not as sufficient. I'm talking about production. I'm not talking about development or testing, right? So what you have to do is at least to have the IO1 as a storage class for your solution. Then this is a very simple way to set up your PXE cluster. You have the directive here. You set the memory request in terms of in memory, the CPU in cycle, and then you set the different storage and whatever. This is the default, and this is the modified. Now, let's start with the most important thing. The request and the limit. The first difference is that I add the limits. When you use application, normally the recommendation is do not use application on Kubernetes and multi-service. The recommendation is to leave the limit blank and let the Kubernetes handle that. But for database, it's different. For database, you must set the limit. And actually, you need to be very rigid about that. Because if you don't set the limit, all the part related to the buffers and the auto calculation will be screwed up. And the risk of having the service, the MySQL service, going up to the limit, exceeding the limit, is very high. And you will have an out-of-memory kill from Kubernetes. That's mathematically sure. Actually, it happens all the time. The other point is the probes. You have few probes that actually check how the operator is, how the MySQL nodes are working, the different pods are working. But the probes are scripts, are things that connect to the node, to the MySQL node, and check, oh, are you okay? Select one, right? The infamous select one. Are you okay? Yes, I'm okay. And that's it. But what happened is that the defaults are very low, 15 seconds and 5 seconds. And if you have a cluster that is hammered in that moment, is very busy, it may take sometimes to answer. It's working perfectly. It's serving the query. It's just queuing the thing. Yes?
Is there an exporter for this for like DMM or something?
Exporter for this for what?
For something like DMM, if they want to export the probes or
Information about, well, there is the exporter for MySQL for sure, and we have some statistics also for Kubernetes. Yes, and yeah, for a PMM there is something. It will come up soon as well, because if you want, I will introduce you to one of my colleagues that is designing exactly that. So the point here is that whenever you roll out something in production, you should not leave the defaults like this one, but you need to change and adapt the defaults to what makes sense in respect of what is the foreseen data load. Let's see why it's not working. Okay. Then the other component that is very important is HAProxy, right? HAProxy have the same problem about the probes, plus the other thing that you can set are all the different timeouts and settings that you can, as you normally will have in the standard solution on Iron. Just not in the, just in the Kubernetes, the settings are different. You need to be careful. And the backend information that are in a different place. Now, ProxySQL, who is using ProxySQL? 1, 2, okay, fantastic. You know that ProxySQL is a great tool. I love it. I've been promoting it for years, right? But for operator and for the Percona operator, but in general for operator, is not the right solution. We have you can deploy the Percona operator for MySQL with ProxySQL because it was one of the many requests that comes from customers, people like you, but it's not the right solution. There is a blog from me recent that it shows how comparing, it actually compares HAProxy, ProxySQL, and MySQL router, and it shows that HAProxy in this kind of situation is the solution because it takes less resources for memory, less resources for CPU, and it scales much better than the other two. Okay, so you can assign less and get more using HAProxy respect to ProxySQL. But ProxySQL play an important role outside. So you can add the ProxySQL to your application pod or application solution and point the HAProxy endpoints and do the read-write scaling, read-write splitting there, do whatever firewalling, do whatever caching you want, just outside the pods, so not inside the Percona operator MySQL solution. And this is actually the data coming out from the blog that I was mentioning before. As you can see, HAProxy is the orange one, and it actually works fine up to 515 threads in using sysbench in a intense load. And while you can see in the same, by the way, this kind of test was run on a very small deployment. I was assigning only 2 gigabytes to the solution, only 2 gigabytes and 1.5 CPU. So I was really conservative on MySQL. I mean, right? And for the proxy, it was I don't remember. If I don't remember wrong, it was just 200 units for CPU. So it's nothing. I was giving very low level of resources, and this is what comes out. I mean, of course, I mean, HA proxy is the one that works better for that. Now, I know this part is very boring. Okay, oh my God, it's too much, too many things to set, too many things to take care of, and we know. This is why also internally, we had a discussion, and the technicians that are developing the dbus system in Percona comes to me and say, Marco, this is absolutely crazy, right? We cannot deploy something without having a way to calculate all the different parameters that make sense for when we deploy the solutions. So I wrote this. Is a MySQL, the name is horrible, MySQL operator calculator, which is a tool that is written in Go, you compile, it runs as a service, you just query through API, you get the dimensions, you have a few indications of what you can ask, and then it gives you all the parameters that make sense to include in your CR file in order to have it running successful. It takes into account the memory that you will have available, the CPU that you will have, and the type of load, which means that is also considering if you have more read, more write, what kind of load distribution you will have there. Now, what's going on? It's not working? Okay, let's go here. Okay, backup. As I said, the other part is that having a solution like the MySQL for MySQL operator for MySQL is useful because you don't need to take care about, you don't need to worry about backups anymore. It does all the thing for you. And this is the definition, right? In the CR, you define that. You define, for instance, in S3, the destination where you want to have for point-in-time recovery, on demand, for schedule, and the schedule, and it goes. That's it. Nothing else that needs to be done from your side. Everything is done automatically. Now, use the right tool for the job. I feel myself like that sometimes, right? When with customers coming and asking something, or when I start to work with the operator and with Kubernetes, because when I start to work with all this, I hate it. Really, I hate it. I say, well, no, how you can use the operator and the database on pods, and this is it's crazy. It cannot work. And then I realized that the problem is the mindset, right? You need to really change your mindset, but not that you have to become a developer. This is a different thing. And I came from development because in '87 I was a developer. But you have to understand that it fits specific needs. It fits specific situation. It's not a solution for all the cases. And this is why I'm saying it's a good tool, but you need to be careful when you use it and contextualize correctly. Okay, so just summing up, few consideration. Move to microservice was an answer to provide better performance, flexibility, scalability, and whatever other ability you want to add. And that works great for application, for code, and whatever. It doesn't work for relational database. unless you shard. Keep in mind that you can shard also without using, Kubernetes and pods and whatever, right? So the sharding solution is anyhow a solution because you reach the limit of your write scalability. So again, the operator could help you in sharding, not because the sharding per se, but because the management of the volume, of the number of different shards that you will have. So the manageability will increase because you have automation thanks to the operator, okay, and the solution. And of course, before moving, you need to understand how the container Kubernetes work, the limitation, how the whole mechanism of service by pods works, and cannot be done, in blindly without a deep analysis at some time to spend over. Otherwise, you will not sleep during the night for the next years. And okay, as I said, it's not a blanket solution. Keep in mind that MySQL doesn't scale in write. It's one scale up, in read scale horizontally, in write it doesn't scale. Do you know what is the only solution that scales write actually horizontally in MySQL ecosystem? There is one. No? None of you. Okay. Have you ever heard about NDB? Yes. NDB is the only solution that actually scales write horizontally. More nodes you had, more write you have, more nightmares you will have as well, but it works, right? And is actually the only solution. Actually, it's a perfect fit for the operator. I wonder why nobody thought to do it, but it's the perfect fit. Because it's too complex. I'm telling you why nobody did that, because it's a very complex product to deploy and to maintain. Keep in mind, bigger the dimension of your data set, longer will be the time to recover. So you need to consider that in relation to your RTO or PO. And there is no way to have a one-on-one matching between application, microservice, and database, because unless you move you break the relational model. And this is a personal consideration. If you go for shard, also with Vitess, because Vitess allow you to do multiple query against different shard, and get the result set, so a joined result set. But if you are in the need to have efficient query against a large data set, I really do not understand why you cannot move in order to have your organization on shard and then consolidate everything on a columnar organized database or all-up system that actually is done for that purpose, to provide you analytical information and data against millions of rows, and not instead having to query and to pollute the system with query that can actually slow down all the other systems as well. I don't know what is your experience about that with Vitess. I heard that you were having some, Okay.
In some cases we do, but we try not.
Okay, but again, you have the both solutions. That's the point. So you redirect to the all-up system what makes sense there, and this is exactly what you should do. Okay, and in case you just you are looking at doing to adopt Kubernetes and operator pods and whatever solution just to simplify your life in terms of management. I also have a simple question, right? Can you do the same with simple automation, with Ansible or something like that? Because if you can do that with that level of solution that is already in-house, fine, right? Because adopting Kubernetes and all the other, and all the thing that comes with it is a big jump. And it's something that is very complex. So if you can cover the need of automate thing with simple automation that your DevOps that you already have in-house, do that. And then if not, you can move to, solution like Percona operator from MySQL. And that's it. I don't know. Yeah. Any question? No, I was so boring that. Yeah, I was boring. Right. No.
Is there a use case that you would recommend asynchronous replication within the Percona Kubernetes operator?
No. Don't burn me with your eyes. His product manager for Percona product manager for MySQL. But no, I don't think is the right thing to do, because the concept again is whatever you roll out, a module is the service is composed by primary and secondaries, right? And multiple pods. And the problem is that these pods can be killed by anything like, as I said, network problem. And if you do not have a replication mechanism that is keeping the node in sync as much as possible, so what I'm saying is, synchronous replication, then what will happen is that you may have, for sure, in asynchronous replication, what will happen is that you have the primary with data up to 100, and the secondary, that the last data they received is, I don't know, if you're lucky, 80, right? So you have a gap of 20 entries. And if you do that, what happens is that the primary goes down, I shift the traffic on the secondary, and the secondary missed the entries for 20 entries, right? So unless UDBA goes there and say, okay, go ahead, I should stop the write traffic. And also if I allow the reads to happen, the reads are going to be still read in respect to the primary. So what's the benefit of it? Make sense? No, because sometimes I look crazy, right? But, okay. Anything else? Well, thank you very much.